this Ansys Fluent tutorial. Today we will be covering overset mesh, a basic of overset mesh. So let's start. I have already opened the workbench here and just drag and drop mesh. We need to create more than 2 mesh for overset grid. So let's start. Just drop one mesh. Rename it as a background mesh because we will be using it as a background. And then drop another mesh. Rename it as a cylinder and one solver. We will be using Fluent as a solver, so just drag and drop Fluent and rename it Fluent. So double click the geometry. If you are using old version of Ansys like version 17, then you might see a design modular here, but in version 18 design modular is replaced by a space claim. So if you're using old version, then you have to design the same geometry in design modular, and it is very easy to design geometry on design modular also, but space claim is good compared to design modular. So let's start geometry here. So I'm also using it first time space claim actually. So we need to create a rectangle and sketch plane. We need to select a sketch plane. This is sketch plane, and let's create a rectangular block here. And the dimension will be 700 mm width and 100 mm height. And let's fill this. Let's create select first and select this and Control A and press fill. Computer is very slow. Let's pan it here to see the complete section. So this is our rectangular block in which this will be the inlet, this will be the outlet, and those are both maybe we will define them as a wall, or maybe we will define them both as a pressure outlet also. So let's move to second geometry. So now we need to design a cylinder. To create an overset mesh, we need to define a cylinder at the center of our plate and a distance from 100 mm from the front. So let's draw first a 100 mm line and then a 50 mm line. So now let's select the first line and 50 mm and oops, what happened? It's 30 mm, so create this as 100 mm. Now select both and yep, it's good. And now create a circle at that point. Our cylinder diameter will be 10 mm. Nope, our cylinder diameter will be 5 mm. And our overset mesh diameter will be 25 mm. And now create a line to control a mesh from here to here. And now delete those structure lines let's bend a little bit. And select this, and this, and this, and this, and press fill. Now we have a, and delete this surface, we don't need this. So yep, our second geometry is completed now. And now we can move on to meshing. In case of overset meshing, we can create a structured mesh for even a complex geometries. What we do is we break geometries into simple parts and then create a structured mesh for those parts, and then we append those meshes in a single mesh with the use of overset meshing. So let's start mesh for our background. As we already open the Ansys meshing here, this is our geometry, and first we will name the boundaries. So select the edge selector and select this and this edge, and right click and create name selection and name them as a pressure outlet. This edge is also outlet, so name them as outlet. This will be our inlet, so named an inlet. Okay, and now first introduce the method here. This will be geometry and all quads, and now insert a sizing. Create here a name selection. This will be easy, I think. And pressure outlet. Number of divisions. Number of division here will be 350. Uniform. So make sure it is ticked. Behavior should be hard. Otherwise, Ansys meshing will use its own technique to mesh this geometry, and you will not get a structured mesh. Again, insert a sizing. This time choose this and this inlet and outlet. Press apply, select number of divisions, and it should be like what we can do is 65. Behavior should be hard, and we will introduce this bias here. Bias factor we will choose it as 8. See that your bias factor is working or not, you can zoom here, and as you can see you have a high density in middle and lower density as you go away from the middle, so your bias factor is working fine. And in last, introduce face meshing. First select the boundary quadrilaterals method, and let's generate our first mesh. That's great. It looks great. That's good. So now let's name. We already have named the boundaries, so let's move to mesh of second geometry. Again, double click the meshing, and this is our second geometry. And again, first name the boundaries. Select this and this. Create right click and create name selection, and name them as a cylinder. Press OK, and this time select this and this, and create name selection and select them as a overset. press OK. And now again, first insert a method, select a body, press apply for all quads. And now select sizing and select edge selector, select this and this edge, hit apply, select type, number of divisions, and number of divisions here should be 50, and behavior should be hard, and we don't need any biasing here. Again select sizing, press this and this edge, hit apply, and again select number of divisions, and behavior should be hard, and bias type, I guess this will work, I think, and bias factor should be 1.4. And let's generate our first mesh, or first insert a face meshing here also. Hit apply, all quads. Okay, now we are ready to generate our first mesh. Let's generate it. Oh, that's quite interesting. Oh, that's because the number of division here is just 1. We have to increase the number of division here up to like 25. Let's generate a second mesh. That's good. If you want a more precise mesh, you can increase bias factor here and generate, and you can also increase the number of division here, but I'm happy with this mesh. If you will increase the mesh elements, then you will need a more computing power to generate a solution, so I'm happy with it. So now let's move to Fluent. Before starting the Fluent, we should connect the meshes to the Fluent. So press a mesh and hold the mouse first button and drag it to above this setup icon here, like this, and drop it there. And again do the same thing for this mesh also, and press update, right click and press update. And do the same thing for this mesh also, right click and update. And now double click the setup. Please make sure for overset meshing double precision is recommended, and I have 2 cores and 1 GPU, and I will choose Intel API. It works great with Intel processor, so press OK now. So this is our geometry. It is showing a warning. I know why it is showing this warning. We will take care of that. So let's first see. This is our background mesh, and this is our cylinder mesh, which is perfect. As you can see, our cylinder is in the center of our background mesh and 100 mm away from a inlet boundary. So let's first scale, and mesh was created in mm. We will enter it in mm and press close, and time should be transient, and double click models and fresh viscous laminar, and we will be using K omega model here. Curvature correction, press OK, and material here will be fluid, will be air, and solid will be aluminum. Cell zone condition, yes, cell zone condition will be here of fluid fluid, press OK, and for system surface fluid and press OK. And let's move on to boundary condition. Boundary condition in inlet we will use as a 30 meter per second as a velocity, and we will choose intensity and hydraulic diameter. Turbulent intensity will be 5%, it's okay, and hydraulic diameter will be the diameter of a cylinder, which is 5 mm. Press OK. Outlet, yes. Pressure intensity at the outlet will be the same as inlet intensity, 5, and hydraulic diameter will be 5. Press OK. Pressure outlet, I think the hydraulic diameter here will be a little large. I'm just guessing it, so solver will automatically correct it later. So I think I will go with 8. No, I will go with 10 here, and press OK. And overset will be overset, and these two will be interiors and interiors. So let's create our overset interface. Make sure if you're using an old Ansys version, then you have to manually select this type as overset boundary type, and then you will see this option here, overset interface. Otherwise you will not see this option here. Press double click here, create, and name this as overset over, and select background zone, component zone. If you're not seeing here any background zone, then you are using some type of boundary condition, overset boundary condition in background zone. You should change the boundary condition to some type of ordinary boundary condition, not overset boundary condition in background zone. Fluent does not permit any overset boundary condition in background zone, otherwise it will be considered as a component zones. So let's create it, and as you can see, overset interface is created. And let's control our report definition. Actually not. Let's go directly to monitors, residuals, and we will lower our residuals up to 10 to the power 5, -5. And copy, paste it here, and paste it here also. Press OK. If you want a lift or drag coefficient of cylinder, you can create it from here. Residuals, definitions, new, force reports, and drag and lift coefficient are also, you can create it from here. In old version you can directly create it from here, but they have removed it in new versions, so that's not a problem. Let's first, to see our first overset mesh, we should first initialize the problems. And for initialization you can create directly from solving, but if you're using old version like 17, then you will not be able to initialize it hybridly. In 17, Ansys not support hybrid initialization for overset mesh, but in version 18 it supports it, so I will go for hybrid initialization. If you are not getting in hybrid initialization, then you should go for standard and compute from all zones and click initialize. Okay, I will be going for hybrid initialization. And now in calculation activities, make sure it is time step should be 1. And one more thing, that if you are using overset meshing, then CFD post will not be able to accept your solution data, because CFD post doesn't able to understand the overset mesh data. So you have to do post processing in Fluent only. So make sure you make your calculation activity according to that. So I will not export any calculation activity because it will be useless. So let's solution animation. Let's go to solution animation, and I have to create a solution animation here in Fluent. So let's create a velocity animation and record it after every time step, and format HF, stores directory, window 83, and let's create a contour. Make sure all zones are selected. Velocity and X velocity. Save and display. Close. Oh wow, that's a very good visualization. Record after 1 minus active 23. Enter 1 and okay. And now let's go to calculation. Time step size should be 0.001. You can decrease time step size to 0.001 also, but it will just take more computing power. I'm happy with that. 0.001, and number of time steps should be 200, and next iteration will be 30. And let's start the calculation. Just ignore this warning if you are getting this warning. This is basically a residual plot, and which shows that how your solution is converging, which is currently it is not converging. As you can see, it goes down here, converged, and for next time step it goes up, and this time step is not converged, and in this time step it converges very quickly, as we have only given a max 30 iteration. So I don't think our calculation is going in the right direction, but we will see a result. You can change the boundary condition a little bit to get a good result, but I'm happy with it. It is just a basic introductory tutorial to overset meshing. You can change boundary condition according to that. After the calculation, this is our residual plot. As you can see, it is completely irregular and our solution is not converging. You can improve this by changing the boundary conditions and hydraulic diameter. So let's see our animation, solution animation. As you can see, our solution animation is also irregular, which is not good. Let's see some contours here. Let's see the contour of turbulent kinetic energy. And yeah, so I'd like to show you what is overset mesh actually look like. For to seeing overset mesh, just click overset icon here and display. This is overset mesh look like. In overset meshing, there are some donor cell and some receptor cell. Donor cell actually convey the data to receptor cells. As you can see, some nodes are connected here, by which donor cell give data to receptor cells, and this is how overset mesh look like. I hope you like this tutorial, and if you have any comments and any questions, you can put them in comments box, and subscribe to the channel. Thanks for watching this video.